Jai Hind everyone, I am from Indian Space Team PR department. Ever wondered why Mars, our neighboring planet, is often referred to as the Red Planet? Let's delve into the fascinating physical characteristics of Mars to find out. Mars, in comparison to Earth, is about half the diameter. It has a surface area slightly less than the total area of Earth's dry land. Despite its smaller size, Mars is less dense than Earth, possessing roughly 15% of Earth's volume and 11% of Earth's mass. This results in Mars having about 38% of Earth's surface gravity. Now let's talk about Mars as a desert planet. It's the only example we currently know of a rocky planet with a surface akin to those of Earth's hot deserts. This is a unique feature that sets Mars apart from the other planets in our solar system. But what about its distinctive red-orange appearance? The answer lies in the presence of ferric oxide, or as we know it, rust. This rust gives Mars its iconic color. Depending on the minerals present, the Martian surface can look like butterscotch and can even appear golden, brown, tan, and greenish in color. But Mars is more than just a red planet. It's a world full of geological wonders and mysteries waiting to be unveiled. Its surface tells a story of a planet that has evolved and transformed over billions of years, just like our own. So next time you see Mars shining red in the night sky, you'll know it's not just a color, but a reflection of the planet's fascinating physical characteristics. Let's dive deeper into Mars, literally. What's at the heart of this intriguing planet? Just like Earth, Mars has differentiated into a dense metallic core overlaid by less dense materials. Current models of its interior imply a core consisting primarily of iron and nickel with about 16 to 17% sulfur. This iron sulfide core is thought to be twice as rich in lighter elements as Earth's. The core is enveloped by a silicate mantle, a layer responsible for many of the tectonic and volcanic features on the planet. Despite its impressive resume, this mantle appears to be dormant. Besides silicon and oxygen, the most abundant elements in the Martian crust are iron, magnesium, aluminum, calcium, and potassium. These elements join forces to create a crust, with an average thickness of approximately 50 kilometers, reaching a maximum thickness of 125 kilometers. Now, you might be wondering how this compares to our home planet. Earth's crust averages 40 kilometers in thickness, making Mars' crust substantially thicker. In 2021, scientists made an exciting discovery. Based on 11 low-frequency Mars quakes detected by the InSight lander, they determined that the core of Mars is not solid, but liquid. This Martian core was also found to have a radius of about 1,830 kilometers and a temperature around 1900 to 2000 degrees Kelvin. Interestingly, the core radius of Mars is abnormally large, accounting for more than half the radius of Mars. That's about half the size of Earth's core radius. To this, it has been suggested that the core contains some amount of lighter elements like oxygen and hydrogen, in addition to the iron-nickel alloy and about 15% of sulfur. So, what does all this mean? It means that Mars is not just a red spectacle in our night sky. Beneath its surface, Mars is a metallic marvel with a core rich in iron and nickel. Its unique internal structure and fascinating geological features continue to intrigue and inspire us. With a core rich in iron and nickel, Mars is not just a red spectacle, it's a metallic marvel. Did you know that Mars, like Earth, experiences its version of earthquakes? Yes, these are known as Marsquakes, and they provide a fascinating insight into the inner workings of our neighboring planet. Mars is not just a static, immovable body in space, it's a dynamic, living planet, much like our own, with a beating heart at its core that sends tremors through its surface. These Marsquakes are detected and recorded by landers like InSight, which, although now offline, has significantly contributed to our understanding of the Red Planet. Throughout its operational life, InSight detected and recorded over 450 Marsquakes. These seismic activities have painted a vivid picture of what lies beneath Mars's surface. Each Marsquake is like a ripple on a pond, providing clues about the composition and state of the planet's interior. One of the most significant discoveries resulting from these Marsquakes is the confirmation of a liquid Martian core. It's not just a solid ball of iron and nickel, but a churning fluid entity. This discovery was made based on 11 low-frequency Marsquakes detected by the InSight lander. It's a revelation that has profound implications for our understanding of Mars's geological history and potential for life. Furthermore, the size of Mars's core has been a subject of great interest. With a radius of about 1,830 kilometers, it's abnormally large, accounting for more than half the radius of Mars. In comparison, it's about half the size of Earth's core. Such a large core suggests the presence of lighter elements like oxygen and hydrogen, in addition to iron, nickel, and about 15% of sulfur. So when we think of Mars, let's not just picture a static red desert. Instead, imagine a vibrant, trembling planet with a dynamic, liquid heart. Each Marsquake it experiences is a heartbeat, a sign of its geological liveliness. And with each tremor, Mars unveils a little more of its secrets to us. Yes, Mars trembles too, reminding us that it's a dynamic, living planet. If you thought the Earth's mantle was fascinating, wait till you hear about Mars's mantle. Much like our home planet, Mars also boasts a mantle. But the Martian mantle is a different beast altogether. It's a rocky layer that sits right over the metallic core, a cloak of silicate that has shaped many of the planet's unique tectonic and volcanic features. But don't be fooled by its dynamic past. The Martian mantle appears to be dormant now, silently holding the secrets of Mars's geological history. Unlike Earth's mantle, which is separated from the core by a thermally insulating layer, Mars's mantle lacks this feature. This absence of a buffer zone may have significant implications for the planet's past and present seismic activity, and it's a clue that the internal structure of Mars is not a carbon copy of Earth's. Now let's delve a little deeper. The Martian mantle appears to be solid down to about 311 miles, where the partially melted asthenosphere begins. This region is often referred to as the low-velocity zone, a name derived from the slow speed at which seismic waves travel through this partially molten layer. As we go further down, the seismic waves start to pick up speed once again, marking the boundary of the transition zone extending towards the core. This boundary lies at an approximate depth of about 652 miles, and it separates the mantle from the core, marking a significant change in the physical properties of Mars' interior. The mantle isn't just solid rock, though. Recent data from the InSight lander has suggested the presence of a liquid core, a finding that adds another layer of complexity to our understanding of the Martian mantle and its links to the planet's seismic activity. Mars's mantle, much like its surface, is a testament to the planet's dynamic and intriguing nature. As we continue to explore and study Mars, each discovery peels back a layer of the red planet's mystery, bringing us closer to understanding our fascinating neighbor in the solar system. The surface of Mars is a geological wonder, but what makes it so special? Mars, a terrestrial planet, has a surface that's not just a pretty face. It's composed of a rich cocktail of minerals, metals, and other elements that typically make up rock. The Martian surface is like a canvas painted with the hues of cosmic chemistry, each color telling a story of a different mineral. At the heart of it all is silicon and oxygen. These two elements form a bond that's at the base of most rocks on Earth, and it's no different on Mars. Silicon and oxygen team up to create the majority of Martian soil, giving it its distinctive red-orange hue. The reddish tint is a result of iron oxide, or rust, within the soil. It's like Mars is the universe's biggest rusted artifact. But the Martian surface isn't just about silicon and oxygen, there's a metallic touch to it as well. Metals like iron, magnesium, aluminum, calcium, and potassium are generously sprinkled across Mars, adding to the complexity of its surface composition. Now, let's talk about the star of the Martian surface, the tholeiitic basalt. This basalt is a type of volcanic rock that's rich in iron and magnesium. It's the primary composition of the Martian surface and is responsible for giving Mars its characteristic rugged terrain. But wait, there's more. In certain regions of Mars, the surface has a low albedo, which means it doesn't reflect much light. These regions suggest concentrations of plagioclase feldspar, a common mineral in the Earth's crust. This introduces a new layer of diversity to the Martian surface, painting it with shades of golden, brown, tan, and even greenish hues depending on the minerals present. From its red-orange hills to its basalt plains, every square inch of Mars tells a story of cosmic chemistry and geological magic. Mars is not just a red planet, it's a rainbow of rocks and minerals, a testament to the wonders of celestial geology. Share this video